Dear colleagues and friends, I'm really sorry not to be with you at this important third international forum of the Challenge Programme Water and Food. I'd like to start by emphasizing that as the chair of the Science Advisory Committee of the CPWF, how impressed we are in the entire advisory committee of the progress and achievements of the entire program, ranging from the great work on water productivity and basin focal projects all the way to the integrated challenges of resilience and institutions and behaviors and the broader challenge of sustainable water resource management in a rapidly changing world. What I'll be doing now is to give you a brief scientific update of why the continued research in CPWF is so incredibly important in the broader context of global change. Now, this is not surprising to anyone in this audience, of course, that we're living on a crowded planet. But what is important to be reminded of that the pressure on the planet is in fact a quadruple squeeze, which we tend to separate in different sectors. The first, of course, being the challenge of demographics. We've just become 7 billion co-inhabitants on the planet. But we should also remember that we are committed to 9 billion people. We know from assessments around the world that we need to increase food production by no less than 50, perhaps even 70 to 90% to meet the Millennium Development Goals and feed a world of 9 billion people. But we also have a 2080 dilemma that the big negative environmental impacts so far have largely been caused by the rich minority, the 20% that stepped onto the Industrial Revolution, and that we have a tremendous positive development momentum right now where the vast majority of inhabitants on the planet are actually moving very rapidly towards more affluence. The other pressure on the planet is, of course, climate change. And here we have another scientific dilemma, which is that we're seeing that the planet is probably more vulnerable to change than we previously thought. Change is happening more fast in terms of sea level rise, ice melt, changes in precipitation patterns, all of which are impacting in surprise and nonlinear ways on societies and particularly on agricultural systems in the world. You would have wished that the climate change pressure occurred on a resilient planet, on a planet that was strong to buffer the impacts. And unfortunately, we know that we are in a phase of unprecedented undermining of ecosystem functions and services over the past 50 years. So we have a climate crisis and an ecosystem crisis interacting with a social challenge. And as if that was not enough, we also know increasingly that surprise is if anything, the universal behavior of social ecological systems, that systems can change gradually over long periods of time and then suddenly, under the pressure of a trigger, fall over a threshold and change state. And together, this quadruple squeeze changes the landscape for human development. It really places a new challenge in terms of global sustainability. It's such a large challenge, in fact, that Nobel Prize laureate Paul Crutzen suggested already in 2002 that humanity may have entered a new geological epoch, the Anthropocene, where we humans, anthros, are the dominating geological force on planet Earth. We're starting to see scientific evidence really converging behind this concept of a new era. You may have seen this, in my mind, very significant special issue in Science on the data around the Anthropocene. As you see here from upper right-hand corner on the risks of ocean acidification, on the left upper left-hand corner, the overfishing of the oceans with 80% downgrading of fish resources. But on the bottom, of course, the hockey stick pattern of population growth and carbon dioxide. We are today hitting the hardwired ceiling of environmental processes at the planetary scale. We also know that this is exactly the pattern we're seeing on water. The freshwater agenda is increasingly connected to the fact that, apart from knowing that freshwater is the basis for human well-being, in this, in my mind, very communicative graph from colleagues in Finland, we see the cumulative data, which we all know so well, that we have roughly 3 billion co-inhabitants on the planet facing water scarcity, and that this is growing, and that we have an exponential growth, not only in terms of water scarcity, but also in terms of exploitation of water resources. We know that 25% of the world rivers do not anymore reach the ocean. The challenge is moreover tremendous on water. We have increasing data from the comprehensive assessment on water management and agriculture to research that's going on in the CPWF that we need, in the upper left-hand corner here, nothing less than some 2,000–3,000 cubic kilometers of more consumptive use in agriculture to feed the world. And that this is already the world's largest water-consuming sector on the planet. In the right lower-hand corner, we also know that irrigation will not be able to do this alone, even though being an absolute precondition, but green and blue water management, rain-fed and irrigated agriculture management will have to integrated together fill up this enormous challenge for humanity. Now, we gathered in May this year a group of Nobel Prize laureates to address the whole challenge and try to define what does this in fact imply for humanity. That resulted in what is now called the Stockholm Memorandum, and a couple of key statements that I think really are key to address also the water and food challenge is summarized here. The first one is that we have scientific evidence that humanity has or is approaching a saturation point, that we've come to a position where if we push the pressures on the planet much further, we cannot exclude catastrophic tipping points. We're also seeing more and more evidence that resilience and managing landscapes, not only for optimization and efficiency, but also for redundancy to deal with shocks, is increasingly important. That climate change is but one factor in the whole challenge of global sustainability, and that business as usual will not be an option. We cannot go on just optimizing on the margin. We need major global transitions, also in agriculture, in order to zoom in and meet global sustainability targets. This places a new challenge for the research that we are representing in this room, to connect human development with global environmental change and agricultural water resource management for livelihoods and development. And no doubt is there a very dramatic conclusion from this, that it appears more and more that global sustainability is now a prerequisite to attain the UN Millennium Development Goals. It's not enough to do great sustainable development on the ground. We are interconnected across scales, sectors, and in time. Now, this is increasingly understood outside of science. We're normally seeing this kind of headlines in The Economist with the vortex of the financial crisis in 2008. But as you may have seen in May, The Economist welcomes humanity to the Anthropocene. And we're starting to see how these ecological and social interactions are playing out at a larger scale. The Economist, moreover, makes a very nice reference to the science, which is showing that change is occurring faster in the real world than we had predicted, by this typical The Economist British type understatement citation saying, when reality is changing faster than theory suggests it should, a certain amount of nervousness is a reasonable response. And I think that summarizes in a nice way what science is trying to communicate with society today. Now, what's the evidence behind this very dramatic message of the Anthropocene? Well, you've seen it all. This is one of the classics, which is over the past 250 years, the hockey stick pattern of carbon dioxide increase. But it doesn't matter which parameter you choose when it comes to environmental parameters meaning something for human well-being, they look the same, being the sister on temperature rise, but also on nitrous oxide coming from modern agriculture industrial processes, methane from draining of wetlands and coastal zone areas, stratospheric ozone depletion, frequency of natural climatic disasters, overfishing of oceans, the whole issue and challenge of eutrophication and the tipping points it generates in freshwater systems, deforestation, expansion of agricultural land, and finally, perhaps the most important one, that we are in the 6th extinction of species on the planet. All of these, as you well know better than anyone, are connected to agriculture and the management of land, water, and ecosystems. So we have this pattern of an exponential pressure on the planet, and as you see from this pattern, they all bend in the same point. We reached the mid of the 1950s, we're 3 billion people, and we take off in what now is defined as the point of the great acceleration of the human enterprise. And we have now empirical evidence that we are at the top of these curves, and the disciplinary sciences from climate, hydrology, ecology, oceanography, more and more point that we need to bend these curves now, very soon, in order to avoid the risk of tipping points coming in the decades and centuries to come. So it is indeed a very decisive point in time to address the future of sustainable water food research in the world. Now, one thing that we need to recognize, and we do in the kind of research that we are carrying out on the whole scene of water and food, is illustrated in this graph. This shows the great acceleration. It's from National Geographic, from work from Will Steffen. And you see here in 3 axes the human affluence, population, technology equations. So on one axis you have population, on another axis, the y-axis, you have a measure of affluence and GDP, and on the other x-axis you have technology in terms of number of patent applications. And the little box right down in the bottom is our footprint in 1900. And then the second box, which is slightly larger, is our total social ecological footprint in 1950. And then the large box is today. So you can see very clearly the takeoff which occurs from 1950. And the interesting thing is that the pressure and the size of this box is particularly the production and consumption of stuff. It is our affluence which is driving the major pressures today, which has all to do also with consumption patterns. So that's the predicament we're in. Now, if that's the pressures, then we need to connect that also with the understanding of nonlinear dynamics. And we have increasing evidence that ecosystems, social ecological systems do not behave as we've often stipulated that they should. We often think in the upper left-hand corner here that ecosystems, when you put pressure on them, when we exploit them, that they change gradually and linearly. But we're seeing more and more evidence that, in fact, systems have multiple stable states, separated by thresholds, and that we can push systems across thresholds with abrupt and often very irreversible situations which are difficult to reverse back. And we have today a battery of evidence around these kind of tipping points, often illustrated here in this cup and ball diagram, where the depth of a cup is a measure of resilience, the system illustrated here as a little circle, and that systems which are in good health, like high biodiverse rich fish delivering coral reef systems, clear water systems, productive savannas, over many decades are exploited and managed, and they do deliver ecosystem services, appear to be healthy, but in fact the resilience is gradually lost. We are lulled into a comfort zone of limited incremental change, but then we have a trigger that suddenly pushes the system across the threshold due to the loss of resilience, and the system is locked in a new state when a feedback hits in. And the key is that we're starting to understand these feedback mechanisms more and more, and many of them are linked to feedbacks in water resources, drying out of water balances, changing in partitioning points, drying out of soils, which locks systems in undesired states. We're starting to see more and more how the living biosphere plays a role in these tipping points. This seminal work by James Estes and colleagues on the trophic downgrading of planet Earth, showing that apex consumers plays a role, even in agricultural landscapes, to keep the food web in balance and to avoid cascading effects when you lose biodiversity, kicking in feedbacks which degrade systems from eutrophication to steppe developments and savannas. So we're truly in an integrated land-water ecosystem challenge here. Now, the question then is, what happens when you combine the insights of the Anthropocene, the pressures on the planet, with the insights of the risk of catastrophic regime shifts? What happens when you combine global change with the insights of resilience? What happens if we need to put the planet into this whole notion of stability? And to ask this question of whether we're putting pressure on the planet to a point where we can destabilize the global hydrological cycle, for example, destabilize productive agricultural land, we need to know what is our desired state. And as you know, that is increasingly quite easy to define, or at least there's a very good and plausible scientific story here coming out of ice core data. And here's a very interesting sequence over the last 100,000 years. It's interesting because it's roughly half the time we've been fully modern humans on the planet. On the y-axis here in temperature, a good proxy for living conditions on the planet. This is data from the northern hemisphere. It is corroborated by southern hemisphere data as well. And as you know, during most of this time, we had a rough, very jumpy journey indeed. We are having tremendous variability in water, in temperature across this period. We're hunters and gatherers. We live between 20 to 40 million people on the planet until we enter this extraordinarily stable state, the Holocene, a period where the temperature on the planet varies with only 1 degree plus minus, and we are barely into this period and we invent agriculture. We become sedentary, domesticators of animals and plants, and off we go in the Mesopotamian irrigation empires all the way through the Inca, Maya, Chinese, Greek, Roman empires up until the great acceleration point in the mid-50s, 3 billion people, today 7, committed to 9. we know of no other stable period that can support the modern economy. And therefore the Holocene becomes a good reference point of the stability domain for the planet, which also enables us to identify what are the environmental processes we then have to be stewards of to keep the planet stable. And that led to the whole notion of planetary boundaries and the analysis of trying to define in green here a safe operating space for humanity. And I won't go through this in detail, just to remind that it's not only climate change, but this research indicates that freshwater use, land water use, rate of biodiversity loss, eutrophication of both the nitrogen and phosphorus cycle, air pollution, ocean acidification and chemical pollution are all integral parts of the stability of the planet. And immediately you see that essentially all of these are tightly interconnected to agriculture, both as a driver and to being impacted by. So agriculture really has a tremendous role in being a solution to operating within a safe operating space. Now, just to give a couple of last slides on how does this change science then on water food ecosystems. Well, the first is, of course, the fact that today, or so far, the planet has been our best friend. The planet is actually operating in a way where it tries to remain in the Holocene stability domain by buffering our disturbances. And here's one illustration. What you're seeing here is the emission of carbon dioxide over the past 50 years. We go from 4 to 9 billion tons of carbon. Carbon is a long-living gas in the atmosphere. Recent research shows that it has impacts over 1,000 years. So it's the integral under this curve that should have caused roughly 0.8 degrees warming so far. But as we all know, that's not the case. In fact, oceans and land absorb roughly half of our emissions. So we have the world's largest free ecosystem service operating right now in terrestrial and aquatic ecosystems. And it's the gray area under the curve here that has resulted in warming so far. And that we see something remarkable, namely the planet is operating just like resilience theory would stipulate, because we know increasingly that just 50 years back, the carbon sequestration was roughly 2 gigatons, and today it's 4. So the planet is trying to remain in a stability domain by being our best friend. Now, unfortunately, science indicates that we cannot count on this free service endlessly into the future, and that active stewardship of landscapes is a key to be able to sustain this ability. And of course, agriculture being the largest dominating use of land, covering 40% of the terrestrial land area, is the number one solution here. It also means that science must increasingly look not only at water productivity and integrated water resource management under static assumptions of water availability. We also need to recognize that moisture feedback and the resilience of the hydrological cycle is a part of our research agenda. This is work by Hub Savinay and colleagues showing in red here the regions in the world that do depend to more than 60–70% of moisture feedback for its own rainfall, meaning that China, for example, depends on management of land in the Western Eurasian countries for its own rainfall to a very large extent. This, of course, addresses a new dimension in an era of Anthropocene in terms of water resource management. We also know that systems will collapse, and in crisis, we need to identify the sources of resilience to use crisis as an opportunity. And we have ample examples from the greening of the Sahel right now, to management of the Australian Great Barrier Reef, to landscape management in wetlands, where crisis can be transformed into opportunities, and we need to identify those sources of resilience. We also know that we're facing a new green revolution, and that this is a new type of green revolution that has to meet global sustainable development goals while producing more wealth and food, and doing that in ways which is more robust to unavoidable shocks and stresses. This is a tremendous challenge, but increasing research shows that it can be done. And in this week's Nature, we have a synthesis in this area, Solutions for a Cultivated Planet, which suggests, as you may have seen, that sustainable intensification on current cropland to sustain biodiversity and ecosystem functions in adjacent landscapes is a possibility with current technologies. Water productivity, energy efficiency, land productivity, closing yield gaps, and working with integrated solutions on governance, institutions, and livelihoods. And this is, I think, a very promising agenda for us forward. So to close, just a couple of concluding remarks. The first is the obvious for everyone here, of course. Water and food is the basis for human prosperity, which is why one can say that the grand challenge for humanity is in fact water and food, because the challenge is prosperity in the Anthropocene. we do face new challenges on the whole agenda on water and food in the Anthropocene. Suddenly we are entirely interconnected. The farmer's field in Burkina Faso is today in real time dependent on how the atmosphere operates, how the global hydrological cycle operates, which is linked to anthropogenic change because we are now a geological force. Global sustainability is a precondition for human development also at the local scale. We cannot succeed in livelihood improvements locally without addressing sustainability across scales. Improvements and innovations in managing water, land and ecosystems is now, if possible, even more important, because now we not only need to increase food production, we also need to do it in resilient ways, and we also need to be able to buffer what we've defined as water resilience as one complement to water productivity in the efforts that we've done so far. Suddenly it's not enough just to optimize, we really also need to have redundancy and capacity to deal with shocks, from river basins to the global scale. And finally, that there's much evidence that sustainable intensification is a possibility, that a great transition is possible, making agriculture from today actually being a source of the problem to being a very significant part of the solution. And I can see no better community to do that than our frontline integrated researchers on water and food, and many of you are represented in this room. So I, again, am very sad that I can't be with you during the coming days, but I do wish you good luck with the conference and look forward to interacting with many of you in the future. Thank you.